Hello and welcome to this MassMotion webinar looking at what is new in MassMotion 6.0, which is the release just due for release very shortly. So, who have we got online? Well, it's myself, Peter Debney. I should be your host today. But in a moment we've got Erin Morrow and Micah Sankey. They have been creating the latest version of MassMotion for you, and in fact, without further ado, let me pass you over to them, and they will be able to tell you everything you need to know. Okay, Erin?
Okay. Good morning, good afternoon. Thank you for coming. I'm Erin Morrow. I'm the product director of MassMotion, and with me today is Micah Zarki, who's the lead developer for MassMotion. What we're going to talk about today is mostly what's new in version 6. For those of you who are new to the software, I'll do a brief explanation of sort of where the software has come from and what it is we're trying to do with it. But most people will be focused on the new features. So what's new since 5.5, which was the last one out. On the screen in front of you, hopefully, bandwidth is sufficient to see the movie a little bit. It's just a sort of mashup of various different things that have been done with MassMotion over the last couple of years. And it really is just meant to demonstrate the variety of projects from transit to open field to evacuation that have been done with MassMotion. And I guess the one of the things that we're really keen on with MassMotion, especially with version 6, we think that version 6 is one of the most significant enhancements to the feature set that's been made in quite a long time. The really big news for version 6 is that MassMotion has a completely re-architected and redeveloped analysis system, and that's most of what the software demonstration today will be about. The software has also undergone a number of sort of under-the-hood improvements, so there are some slight increases in speed here and there, and we're very actively preparing MassMotion for a bright and vibrant future as well, so that the software architecture continues to keep pace with things like trends in multi-core processing, more and better access to databases and that kind of thing. You'll see how all that transpires in the demonstration. So, what is MassMotion? Well, it is first and foremost a crowd and pedestrian simulation tool, and over the years it has developed into something which is not just for how people move around in space, but also how facilities operate. So there's quite a lot in there to deal with things like the kind of operations you see in airports or security checkpoints and that kind of thing. It was developed initially to serve the needs of very specific large transit projects, and that's always been at the core of MassMotion, that it was designed for people who were working on large, high-volume, complex facilities. And there are a few things that it does to enable that. It is a fully three-dimensional application. It has good links and connectivity with the latest in BIM models, so you can move things over from your Revit models via IFC to MassMotion. But there are paths for getting your 3D data in from just about anywhere via FBX or OBJ format. And it is fundamentally a very powerful tool for considering the implications of design decisions, but also for communicating the effects of those design decisions. And the agents themselves that represent the people moving around in these crowds are what are called fully autonomous agents. So they are capable of making their own decisions about what they need to do to meet their particular goals. And their goals might be quite simply leave the building that I'm in, but they might be much more complicated in that they would have an itinerary, such as check in and get to my airplane, which actually involves going from the curb, choosing the right check-in desk, joining a security queue, finding the way to their gate, maybe doing some shopping on the way. And MassMotion is set up to deal with all of these things. And that speaks to the discrete event process model that's built right into the system. There are several different ways of doing scheduling tied to events in that way. And that's actually a new feature for version 6. And MassMotion is a highly scalable system. It takes advantage of multi-core processing. And we have tested simulations that have over 1 million people in them. So when it came to prepping version 6, we were very keen on getting a very significant upgrade to our analysis system in place. What we really wanted to do was to make it much easier for users to get to answers. You know, MassMotion has always, I think, been a really good tool for building simulations and exploring concepts. But we needed to do more in terms of getting to answers quickly. And so that's why we rebuilt the analysis system from the ground up. We wanted to enable people to compare different result sets directly within our analysis system so that you wouldn't necessarily have to go to an external tool like Excel to compare different data sets. We wanted to make it easier to schedule large, complex models. We're seeing a significant uptick in people using the software for the planning and design of large airports, which have very complex operations that are flight schedule driven and that kind of thing. And as I said earlier, we wanted to make sure that we had a platform which was lean and well configured for oncoming shifts in technology and a bright and vibrant future. So the big bullet points for 6 are: there's a brand new graphical user interface for the software, and you'll see it in the demo, but there's a picture of it. We have multiple 3D views. We've got various different ways of interacting with the objects and finding out their properties within the scene. We have moved from a file stream driven approach to recording simulation data and interacting with that simulation data to a database backend. So it is now a single file that gets created when you run a simulation in MassMotion. And in addition to being a better structured and easier to manage thing, it is also a far superior system for actually going in and slicing through the data and finding the information that you're interested in, which leads directly to the completely redesigned analysis and reporting tools and the ability that users now have to really dig into their data sets and determine cause and effect and where things are good and where things are bad. As mentioned earlier, there's been a really significant improvement to the way, to the options that users have for scheduling things and for managing complexity and scheduling. So with all that in mind, I'm going to turn this over to Micah, who's going to do a quick walkthrough of the way that the software now works.
All right, thank you, Aaron. So like Aaron said, I'm just going to introduce you to the MassMotion 6 environment. The workflow has changed quite a bit from version 5. So authoring is still done in the Optimized workbench and then exported to a folder on disk. But from then on, everything is handled by the MassMotion 6. So we start off here by opening a project that has already been exported. You can see that opening is very fast now in 6. We've got our traditional 3D views on the right with a top right and a perspective view. Maybe we'll just maximize the perspective so we have more real estate. We've got a list of all of the objects on the left-hand side here where we can sort by object type or by name. We can also search for objects by name. Select something and then focus on it in 3D view. You can hide it, show it, select all things, hide everything but those. We have sort of all kinds of different ways of interacting with the scene. Now, this particular model is a proposed design for a new transit station in Toronto. You can see you've got 2 underground rail tracks at the bottom. We've got 3 vertical circulation routes up to the street level. And then at the street, we've got a bus station in the top right corner. The agent pedestrian flows are basically from street into the station and from the station up to the street. So now if we wanted to run this simulation, we have 3 different ways we can run it in 6. We can run it in a highly optimized, performance-focused way using the console. We can run it with graphics enabled, where we can actually interact, or we can interrogate the scene as it's unfolding by running a debug version. Or we can run several consecutive console runs, each time incrementing or modifying the random seed to produce slightly different result sets, which can then be compared against each other later on. Now, users will typically use the console simulation to run because it's the fastest way of running a simulation, but it's not as interesting to look at. So Maybe we'll start with a debug simulation. So the first thing you do when you're going to run a simulation is you need to give it a handle that you'll then refer to the result set with later on during the analysis and playback. So we'll just leave it as the default run. Override what was there. You can see we've got our list of objects on the left. We have a console on the bottom, which will spit out warnings and errors during simulation, initialization, and execution. As with any of the consoles that show up in MassMotion, you can right-click on them and you can change the level of diagnostic information that's printed. And with the scene, you can interrogate it in a number of ways as the simulation is unfolding. You can use some of the debug hotkeys, like selecting the floor and hitting 3. You get a map of the available surface area for walking on the floor, along with red indicating obstacles. You can select the portal in the scene, which is an entrance and exit from the scene, and hit 3. And you get arrows and entrances and exits to all the links, which indicate the distance from that point to the particular portal that was selected. All of these hotkeys are described in the user documentation. You can also do things like select an agent, use the hotkeys to display visual information about how they're understanding their environment. Or you can use the properties pane on the right, and that will give you up-to-the-minute stats on what the agent is experiencing, including a list of all the tasks it's executing, tokens it's currently holding, and a list of all the actions that have thus far been applied to the agent, including a breakdown of sort of how all of those actions were resolved. So if we stop the simulation run early here, that partial data set is now available for playback. Now, traditionally, the result set consisted of a series of ice cache files for playback and text files that could be opened in Excel or the Workbench. That's all. You can still generate all of those if you want, but it's all been replaced by, as Aaron was saying, a backend single database file that then is used for playback and query analysis. So we can now scroll through the results that were stored in that database file. We can do a playback. We can play it back at various speeds. And while it's playing back, we can interrogate the scene in a number of ways, one of which is to get information about each individual agent. So if we focus on an agent, we can open up the agent inspector on the right. We can focus on that agent, and then we get both current time-based stats on the agent as well as lifetime information about the agent. So when it entered, when it exited, which tokens it has ever held during the simulation, along with which tokens it's currently holding, indicated by an arrow. You also get a list of the route that the agent took through the simulation. You can do things like right-click on an element in the route and focus on the time and place at which the agent entered that element, and then watch as the agent sort of moves through the route. Jump ahead right to the end of the agent journey. So you can also use coloring to learn more about how a simulation progressed. So right now, all the agents are colored based on the coloring scheme that was set up during authoring in the Workbench. We can change the coloring scheme if we go and we modify the simulation run. We can change the base color to be something, say, orange or whatever. We can also use more interesting colors, like one based on fluent level of service densities. So then as the simulation playback progresses, the coloring reflects the density that the agent is experiencing. Now, these colors are applied to all of the agents in the result set. We can also use coloring to zero in on particular subpopulations of agents using filtered fraternity concepts in MassMotion 6. So here, if we change the base color back to blue, say, now we'll change the filter color to red so that they stand out. And right now, we're filtering all agents. Let's, in this particular simulation, agents that arrive into the simulation from track level are given an arrival token, and then agents that arrive in street are not. So what we could do is we could filter by whether or not an agent is holding a particular token, holding the arrival token. And if we apply that filter, we can quickly visually see blue agents are departing agents and red are arrivals. You can filter by all kinds of different things. You can filter by where agents entered the simulation, where they exited, what profile they were associated with, token possession, whether they're in a region or not. One of the really interesting ones for digging into why people are doing what they're doing is the selected agents filter. So if we zoom in and we select the number of agents here, and we apply that filter, only the selected agents are shown as red, and then that coloring persists as the playback progresses. And so you can sort of watch what happens to that agent over time, where they end up. Another useful use of the filter is, say we wanted to focus only on the region in the station, and we wanted to ignore the street. What we can do is we can hide the street geometry. And now we can filter all agents that are in the street. We set up a zone already to identify the collections of floors that make up the street. And we'll change the color of agents that are in the street to invisible. Then when we apply that, we do a playback, we see only those agents that are currently in the station and not in the street. Okay, so now I'll turn it back over to Aaron to talk more about the different query analysis tools that are available.
Thank you, Micah. I'm just going to turn a few things back on here. So everything's back on, and turn back on. Turn the filter off there as well. The new analysis system is based primarily, as Micah started to show, on sort of filtering and also trips as a way of drilling in and getting to very specific types of agent populations. What we really wanted to do was to make it possible for people to not only go in and find the particular people and what they were doing in the data set, but to also provide some convenient built-in tools for reporting on what those people are doing. And broadly, those fall into three categories. There are graphs, there are maps, and there are tables. And there are a number that are sort of preset for you. So we've got agent density, flow count, population count, server population count, a number of different maps. And maps are really just a way of applying colors to the various pieces of geometry that the agents can walk on, like floors and links and so forth, so that you can understand things like what the average density was over a certain period of time. There's some interesting things as well where you can set that, time above density, time occupied, time until clear. Those are very useful for evacuation modeling, and even instantaneous density, which is kind of fun to look at. I'm sure that it's hugely useful for reporting. And then finally, there's tables, which are really just ways of going in and digging out particular sets of data about different types of different agents from the database and presenting it in a tabular format. One of the things which is really great about this is that in all cases, you have some options for being able to export the data as well. So you'll see that even if you create a graph in MassMotion, it is also quite possible to export the data which is generating that graph as a sort of targeted data subset if you elect to do something with it in Excel, for example. So let's do a couple of things here. I am actually going to remove this default run from the project space here. And I'm actually going to add a couple of full runs that were created prior to starting the demonstration here. So basically what they are is one of them is this model, sort of as you've seen it running with everything going as planned. And the other one is a version of the model with this entrance here on what is the northwest corner of the model shut down for some reason. So it's really kind of an operational sensitivity test. And we'll call that closed entrance, conveniently enough. And this one is actually going to be coming from a separate project. This is something which is really interesting now, is you can actually connect whatever environment you have open to data sets from a different project. So that will be the key closed entrance one. And there it is. This little symbol means that it's connected. And so we're good to go. We now have two data sets running in here. And if we really quickly change the closed entrance color to red and the open entrance color to blue, then we can go in here and we can see how these two things play out. And what you'll notice up here is that when people, for instance, get off of this bus, which is right here, you will see that the blue population is responding to an open entrance, and the red population is responding to a closed entrance. So the blue people go down, the red people actually have to find their way back across to the main station entrance, which is over here on the northeast of the intersection. Okay, so we've got two data sets, and now let's look at how we might start looking at some of the stuff which is going on here. So we'll start with a simple graph, and what we'll do is we will look at the population of agents in here. So just create a default population count graph. Now it's going to ask us, because we have multiple data sets in here, it's actually going to require that we tell it which simulation run we want to get some information for. So we'll start with the open entrance. For the time being, we'll say the all available time, which is about a half an hour simulation run. And now what we need to do is specify the area that we're interested in getting information for. So we'll add a group, and because I've already selected this object out here, I can just press the plus key here, and it'll add that geometry to something that we're tracking. And we can now evaluate it. So now what we're seeing is a graph of the population in this area for the entire simulation period. Graph searching, you can go in and you can actually select an area that you want to zoom in on. So if I'm just interested in this period of time, we'll do that, rescale the information. The other thing that you might notice here is that there is a sort of dashed line that spans the graph vertically. And that's really saying this is the current time. And if I scroll this, you can see that the dashed line is linked to the progression of the simulation playback. And so it's pretty easy to hone in on times that are quite busy. And we can go in here and we can see, look, there's a whole bunch of agents from the open data set, the open entrance data set that are in this area. So there's a simple population count graph, but what if we actually want to compare the difference between the open and closed entrance? So for that, what we do is we actually go to what we call a composite graph. And what this allows us to do is to effectively look at the same stuff, but we get to compare data sets in here. So when you right-click in this area, you have the option to add a simulation run, which we want to do. And in fact, we want to do that twice. We want the closed and the open. Those things are also available down here from the add button. And then to each of these, we want to add a type of graphing analysis. So in this case, we're going to be interested in the population count. We'll add a population count to each of those. And then what we want to do is, just in the previous one, we want to add a geometry group. And so I select that. Okay. And I want to add a group here. And we'll put that in as well. Now, what I also want to do here is it sort of gives you colors randomly. And what we want to do is just match these colors up with the populations that we're dealing with. So this is the one which is under the open entrance data set. And we know that we've already colored that blue. So we'll just go in here and choose a blue color for that. And actually the closed entrance group is already red, so that's convenient. And now if we evaluate it, we can actually see the comparison between the two. And ultimately what this is just showing is that, if you close the other entrance across the street, this area of the station gets busier due to the fact that people have to reroute and everybody's effectively forced through this area. So moving on from that a little bit, let's take a look at, and I'm just going to close the closed entrance data set, so we just have a singular data set to work with here. So let's say, for example, that we are interested in only dealing with a subset of the population in here. And let's say, for example, that what we're really interested in are people who go from the platform level, say, up to the main entrance area of the station. Well, the way that we can do that now is we can define a trip, and a trip is really just a way of it almost acts like a filter itself. What it does is it helps choose only that subset of a population which goes from one area to another area in the model. So platform to entrance, and what I want is people who are going to be entering the last item. So that'll be the last item, the main entrance. And I'm also keen on getting people who are on the platform. Select that, add it. Now, I've got this a little bit back to front because actually I want people to go from the platform to the main entrance, but that's fine. You can just use these arrows here to move people up and down. So now we've got a trip that we can use to help further define the population that we're interested in. And so we might be interested in, for example, understanding what the overall journey time of people in the model are who take that particular trip. So now we'll look at some table information. In this case, we'll just get a very simple agent summary, which I know will give us the data that we're interested in. And so we'll say, right, we're interested in agents alive at any time. We want people from the open entrance data set. And what we're going to say here is we want agents who are ever in that trip that we defined. And you'll note that you can actually define a trip inline. My personal preference is to define them separately so that they can be reused multiple times, but certainly you can define them inline if you want. So we don't want a new trip. We actually want an existing trip. And we'll select the one that we created earlier. And now we can evaluate that. So these are all the people from that open data set who ever make that trip from the platform through the main entrance. And it tells us lots of things about where they come from, where they're going, start time, the end time, how long they were in the scene, distance traveled, their desired speed. You can also go in and do things like look at for any column in a table, you can actually go in and show a histogram of it so you can see the distribution. Now, the system attempts to choose a reasonable distribution based on the minimums and maximums and the number of samples. But this is all editable stuff, so you can go in and say, well, I'm interested in 0 to 2 minutes, and I'm interested in 2 minutes to 4 minutes, 4 minutes to 6, and so on and so forth, until you get to a distribution which seems sensible to you or tells the story that you're trying to figure out. You can add and remove things, and there you go. This data can all be exported either as a comma separated value, or you can just export an image of the graph itself. Likewise, the data in the table can be exported to a CSV format. And just quickly going back to our graph object to show that So this one, for example, once it's been evaluated, you can export this as a data set, or in fact, you can export it as an image. Just to quickly show you that, just overwrite this one, which I already had in here. Yes, I want to replace it. And now, quickly, I can just go in there and show you what it's doing. And so there's our graph image. And that's ready to be dropped straight into a report if you like. So moving right along, the other thing which is often really important for people when they're doing these kinds of simulations is to understand the patterns of movement within a space over time. So you can, for example, go in and select the sort of concourse area of the station to focus on. So there's the unpaid area here, and there's the paid area here. Actually, just for completeness sake, I will also choose the unpaid area over here on the west entrance. There we go. So now we've selected all the geometry on our mezzanine level. And let's say we want to, for example, look at the instantaneous density for these objects. We create an instantaneous density map, and we decide we want it to be contours or gradients. I'll show you that in a minute. What do we want to show? Do we want a sort of custom density range, or do we want to use one of the inbuilt ones? So we've got various different Fruin ones, plus an airport standard. We'll choose Fruin Auto. We'll add those surface objects to it. We'll click on Evaluate. Oh, I didn't tell it which data set I was interested in. So there we go. And so now we can see that it is showing exactly what's going on in terms of the floor space with the agents as they're currently moving through it. And if you play it back, you can actually see that it is very quick, and it sort of instantly calculates the densities which are currently happening on the floor. Just to show you the difference, you can show it as like discrete contours between the various levels of service, or you can actually set it to a gradient, which shows a more continuous grading of the level of service characteristics. You can set it to a specific queuing, which is more permissive standard in terms of density. And Fruin Auto, I should say, also sort of automatically calculates the difference between floors and stairways in particular, so that you get the correct visual representation of the appropriate Fruin standard for the object in question. Okay, so that's fine. We can also hide this, show it. I'm going to hide it and move on to looking at something which is much more commonly used. This would be something like an average density map for something like this. So again, I'll select a couple of pieces of geometry on the mezzanine, and we'll go to average density. It's fine. Remember to select my data set this time. And this time what I'm going to do is I'm going to say, instead of all the time of the simulation, I want to choose a specific interval. So I want from 8 in the morning, which is pretty much when the simulation starts, to 15 minutes later. And you can choose the sampling rate you want. If you were running very long models, say models which would cover a period of days, you probably want to drop your sampling rate down just so that the calculation times are less. But for a model like this, one is fine. Same options, contours, and which standard we want to apply. And then we want to choose our surface object. And you can do this also by searching in if you know the names, or scrolling through the list and looking for the objects you're interested in. My preference is just to choose them directly in the interface and then move them over. And now what we will do is evaluate this. Oh, that's right. That's 8 seconds, not 8 hours. Okay, so it's going to think about that for a second, and it just goes through the entire database for that time, figures out which agents are in the area at that time, and presents you with the map. And it's nice to know that actually during that 15-minute period, the station is actually performing really well, even if the areas like the turnstiles. If we wanted to get a more holistic view of what's actually going on here, we might turn to something like an agent density graph. Say from that open entrance data set, I want to know for that same interval, 8 a.m., 15 minutes. I'm going to need to create a filter on the fly here to get the things that I want. So I want any of agents who are in this area and also in this area. And that is, I mean, if you wanted to, you could define that filter as an abstract filter, which you could then just reference in this position by saying they're matched by an orange named filter. And they would just be available to you for all these different analyses. But this is fine for now. And right, so we've got all the bits and pieces we need. So it goes here, and now this is for this period of time. These are the densities that are experienced by all the agents on these floors. And we can zoom in further and take a look at this particular peak. Right click and go back out. This one's even bigger. That's an interesting one to take a look at. And if you wanted to, you can play around with your time values based on this, you can play around with your time values for the map itself. So let's say that we know that this looks really busy from about 8:11 through 8:12. So if we go to our average density map, change this to 8:12, or sorry, 8:11, 8:12, and evaluate it. And we start to see a bit more of the activity. And you can see it shifting around a bit. But anyway, the point is that it's actually really useful to start considering the various bits of analyses in relation to each other so that you can actually start to use the graph to pick out what the busiest times are. You can then use that to narrow in on the areas of critical importance in terms of evaluation and population, and to conduct further analysis on that basis. I think that is about it for the demonstration. So happy to take questions, and I'll continue to let this play in the background. And thanks very much for listening.
Thank you indeed, Aaron. Just a bit also earlier that there is the questions box there in your GoToWebinar sidebar. So do please type them in. And Aaron, as it happens, we had one question come in already. Ooh, and more coming in too. Question regarding MassMotion combining with Submerge, which is currently an Arab-only visualization program. Does the new database file work with Submerge?
It does. There is a beta of that tool working with the new database, and hopefully we'll see that go to general release in the not too distant future. Yeah.
Excellent. Okay. Have there been any changes to vision mapping?
That's one which is currently on our desks right now. So the question there is that there was in previous versions of MassMotion the ability to set up surfaces around your model, and you could test whether you could basically record how much time people were spending looking at those surfaces. That tool is in fact still there, but we're not particularly happy with the performance. So a rework of that is on our desk as we speak, and will be forthcoming in a later version of the software.
Excellent. Okay. I've got a question about whether you've got any examples to hand of complex airports. Do you have any available at the moment which you can talk about?
Unfortunately, the answer for right now is I don't have anything on my laptop that I can show a general audience. What I can say, though, is that MassMotion has recently been used to simulate all the concourses at Dubai International Airport, which is one of the world's busiest airports, and it was based on a full day schedule for the airport, and it included all movements inside the concourse, including shopping, movements to and from gates, through transfer screening. Actually, one of the most interesting and sophisticated MassMotion models I've seen to this point. And as Micah just prompted me, it is also it was a very impressive use of the timetable system as well, in that the entire scheduling of agents and their movement to and from gates and to other aircraft, in fact, was based on turning the aircraft schedule into the aircraft schedule, and indeed the transfer matrix were all converted to the new timetable spreadsheet system, and that was what was driving the model.
Do you want to say anything about how the new timetables differ to the old scheduling methods?
The old scheduling effort was based on what I would say the sort of classic transportation model that's sort of origin and destination based. So it allowed you to select groups of origins and destinations, apply weightings or distributions for your population to those origins and destinations. And there were a few other things you could add to it, but effectively it was an O&D based approach to scheduling agents, whereas the timetable based approach is much more geared towards more sophisticated operations, which are dependent on a range of factors, and perhaps the agents having much more to do than just move from point A to point B. And it's also the case that the performance of the timetable system is in fact superior to the old rule-based system, especially when you're talking about something like an airport, where you might have just, when you think about the transfer matrix and all the different populations involved in that, it is a kind of combinatorial explosion of rules, and the timetable does a much more efficient job of handling that sort of situation.
Excellent, thanks. Got a question about validation of the software, because obviously accuracy is very important with these models. Can you say anything about how MassMotion has been validated for evacuation, for general flow, and so on?
Sure. It's kind of a two-stage thing. Every time we create a version of MassMotion for release, there's a quality assurance suite of tests that the software goes through, which is based on comparison to existing documented things like Bruin's level of service. Do the agents perform as expected at the various levels of service through simple but well-documented things like corridors, through doorways, up and down stairs, one-way flow, two-way flow. So all that stuff gets tested, and the results are mapped against expected outcomes. And so I would say that is, effectively a kind of calibration stage of things. Separately from that, MassMotion has been validated against a number of egress and evacuation scenarios where surveying was actually conducted on staged egress events. I can say that it has done very well in those tests. And MassMotion is sort of constantly being tested on a daily basis by people who are using the software on projects, where they're going out and surveying existing conditions and setting up sort of reference models, and then changing those reference models to represent changing conditions. So, yeah, we believe at this point that MassMotion is a very well validated and calibrated piece of software.
Thank you. We've got another question about how you go about producing videos in this in the new version software.
I'm actually glad somebody asked that. So it is now something which is built right into MassMotion. So if you want to create a video of this, actually I'm going to switch it back over to our instantaneous density map, because that's sort of a more interesting one. So now we've got our, let's say we want to see the sort of pattern of people, and let's find a busy time. So we got here about 8:15 to 8:15. Right. So you just click on the movie or image, and you can see that it sort of pops up a replicated version of the scene. You can navigate around that as you would any other view. So get that centered back in there, twitchy. And now we can scroll through here so you can find the position that you actually want. So let's say we're going to be interested in say 8:15 and I don't know 8:15 to 8:16, let's say. So 8. And we want a 1-minute video. You can select the frame rate that you want. You can select the playback speed that you would like to use. You can also select the resolution that you would like. I think on Windows we are limited to full HD resolution, so 1920 by 1080. Unfortunately, to be a limitation of the core Windows libraries for video capture, but hopefully full HD is sufficient for most people's uses. And you can choose to include or not include the overlay information about what's being selected and the population at the time. The other thing which is interesting is that if you expand this window, you can actually see that the sort of grayed out area above and below. And in fact, if you expand it wide, you'll see that that moves to the side. That's basically just showing you what the actual area is going to be captured in. So you can use that to sort of frame up the view that you want. And then you just specify a location for your file. Throw it in here. Call it test vid. You also have quality settings. We're basically recommending that you don't ever go below medium. The low quality is pretty low. Very small files, but it's pretty low quality stuff. And then it's just a question of clicking on a bit of high. So what it's doing now is just going through and capturing all the frames. And when it's done capturing those frames, it will in fact be converting them into a movie, which will take a moment. So I'm happy to answer another question while that's moving on.
Okay. Is there a way to export the agent's traces or routes or other data packages such as 3D Studio Max or GIS?
Yeah, the database file that's created is not in any real way proprietary. There is a schema for it. We're happy to share that with anybody who wants to use it. So you can certainly go in and just pull out all the agent frame data you're interested in. In fact, there are various tools out there, some of them integrated right into web browsers that allow you to conduct queries on SQLite databases right from your browser. So, you can go in and pull that stuff out if you want. It's your data. We're happy to tell you how to use it for whatever you want to do. I should say that there is not, as of now, anything specific for turning that data into something which is 3ds Max friendly or something like that.
And of course, we can still produce the old ice cache files as well and bring those into whatever program we want.
Yep.
Question: can we change the? Obviously, we should show how to change the agent properties, or the colors and so on. Is there an option for changing the object colors in MassMotion here at the moment? Are there any geometric edit tools available here in 6.6.0?
Not in version 6, but that is the sort of, now that version 6 has gone gold, it is sort of out of the development team's hands. The next big thing that we're working on is a very significant overhaul of the geometry management and, in fact, editing side of things. So that's a space to watch, and that will certainly be coming in the not-too-distant future.
Excellent. Okay. I think that covers everything. Okay. Just leave to say thank you very much, Erin and Micah, for that presentation. I have been recording this, so there will be a video going online in the next day or so. If there are any questions still outstanding, there's a closeout survey when we exit, or of course you can email me, and we can discuss things in further detail. So thank you all for attending, and look forward to talking to you soon. Goodbye.
Thank you very much, Peter. Thank you. Take care.